Hi, today I'm going to be presenting 2009 AIME 1, problem number 2. There is a complex number z with imaginary part 164 and a positive integer n such that z over z plus n is equal to 4i. Find n. So the way we're going to solve this problem is, first let's multiply both sides of this first equation times z plus n. So then we get z is equal to z plus n times 4i. Now let's expand the parentheses, and then we get z is equal to 4zi plus 4ni. And we already know z is in the form a plus 164i because it says imaginary part 164. And we have a number if we have a complex number with an imaginary part any number, so for example, let's call that imaginary part x, then the complex number is going to be in the form a constant plus x times I. And in this case, x is 164. Sorry if that confused you, but basically imaginary part 164 is basically a constant plus 164i. So now we can substitute this equation into this one. Z is equal to 4 times a plus 164i times I plus 4ni, because z is equal to a plus 164i. So let's expand, and then we get z is equal to 4ai plus 656i squared plus 4ni. And we already know I squared is negative 1, so we get 4ai minus 656 plus 4ni. Now we can group 4ai and 4ni. When we group them, we take 4i common, and then we get a plus n. So it's negative 656, which is the constant, plus 4 times a plus n times I, because we just took 4i common here. And we already know z is equal to a plus 164i. So that implies that a is equal to negative 656, and 4 times a plus n is 164. Now we can expand these parentheses and get 4a plus 4n is 164. Now divide both sides by 4 and get a plus n is 41. And we already know a is negative 656. So it's negative 656 plus n is 41. Just substituting the value of a here. And then we add 656 to both sides to get n is equal to 41 plus 656, which is 697. So that's our answer.